on behalf of the UCLA Ethics Center, I would like to welcome you all to this year's annual Weinberger-Vermut Genetics Ethics Lecture. I would like to extend a particularly warm welcome to Tom and Leslie Weinberger, who have so generously endowed this lecture over many years and who continue to support the work of the Ethics Center in many other ways. The purpose of this annual lecture is to foster knowledge of the science of genetics as it is applied to medicine and the clinical care of patients, and to evaluate emerging therapeutic genetic technologies in their ethical significance. To achieve this goal, and through the generosity of Tom and Leslie, UCLA's Ethics Center annually invites an individual who is nationally and or internationally recognized as an expert in the field to share with us the latest advances in genetic science and technology, and to help us explore the ethical implications, often challenging, sometimes dilemmatic, that accompany scientific accomplishments of this sort. This year's guest speaker and topic easily meet that expectation. I am very happy to introduce and to welcome Professor Alta Sharo. Professor Sharo is going to talk to us today about a technology known as gene editing, and in particular about the challenges inherent in developing a system of global governance for this technology. In the brief time I have at my disposal, I would not possibly be able to do justice to Professor Sharo's extraordinary CV. I will nonetheless attempt a summary. Professor Sharo, who graduated in biology from Harvard and law from Columbia, is Warren P. Knowles Professor of Law and Bioethics at the University of Wisconsin in Madison. She has also served as faculty in the Department of Medical History and Bioethics at the Schools of Medicine and Public Health there. Professor Sharo has authored or contributed to over 100 articles, book chapters on law and policy related to reproductive health, new reproductive technologies, medical genetics, stem cell research, science funding, and research ethics. Professor Sharo has also a very distinguished CV as a public or civic academician. Professor Sharo served as a member of President Clinton's National Bioethics Advisory Commission and served on President Obama's transition team, where she was a member of the HHS review team, focusing her attention particularly on transition issues related to NIH, FDA, stem cell policy, and women's reproductive health. Professor Sharo is an elected member of the American Academy of Arts and Sciences and of the National Academy of Medicine. In 2005, she helped draft the National Academy's guidelines for embryonic stem cell research, and in 2006, she was appointed co-chair of the National Academy's Human Embryonic Stem Cell Research Advisory Committee. In 2013, she was awarded the Adam Yarmolinsky Medal for services to the Academy of Medicine. More recently, from 2015 to 2017, she was a member of the National Academy's Human Gene Editing Initiative and co-chaired its committee charged with making recommendations on the use of gene editing for both somatic and gene line changes in humans. At present, she is a member of the World Health Organization's Expert Advisory Committee on Global Governance of Genome Editing, the topic she will discuss with us today. No less impressive for some, and I can think of one, is the fact that she hails from Brooklyn, and I thought most interestingly of all, lists poker as one of the activities of which she is fond. After a CV like that, it is very clear that we have not taken a gamble this year on who we are inviting to speak for us. So it is my distinct pleasure to welcome Professor Alta Sharo to give the 2020 Weinberger-Vermut Genetic Ethics Lecture. And can I ask, because of the medium we are using, which makes it impossible for direct questioning of our guest, that if you have any questions, you write them in the Q&A section of the webinar, and our senior fellow, Dr. Alison McCarthy, will put those questions to Dr. Sharo. So without further ado, I would like to hand over to Professor Sharo.
Oh, thank you very much, Dr. Hines, for that very generous introduction. I think more than anything else, what it shows is that you can never have enough good committees. I'd like to spend some time today talking with you about what's going to come up next in the area of genome editing governance, particularly at the global level. I have a number of learning objectives, and I hope to be covering all of these topics before the end of the lecture. And yet, before I begin, I do need to mention that indeed I am or was a member of a number of these entities that had something to do with this topic. I want to emphasize that the opinions expressed in the lecture are my own and don't necessarily represent opinions of the University of Wisconsin or any of these organizations. I'm going to talk about 4 different kinds of genome editing because they raise rather different issues. And just by way of review, I know most of you know this all backwards and forwards. I'll be talking about somatic editing, which is editing of the body except for the reproductive cells. This means these are non-heritable changes only experienced during the lifetime of the person who's experienced the edits, as opposed to so-called germline editing, which is changes in gametes and embryos. There's a subtlety here because it's a germline edit in, let's say, an embryo sitting in a dish, but it's not heritable unless that embryo is actually transferred and gestated to live birth, in which case the resulting child's gametes would reflect those edits. And so when we talk about germline, it's always useful to distinguish between a non-heritable experiment and a heritable reproductive attempt. I also want to make some time to talk about things that don't get nearly the attention that they probably deserve. Those are epigenetic changes. This is change not in the gene sequence, but in the up and down regulation of a gene to alter its function, which might allow for temporary changes that are reversible. And in utero editing, something that is really very early in development, which would be editing of the fetus in utero. This is a form of somatic editing of the fetus. It would be non-heritable because it would be done at a time when the gametes are not affected. But I think you can already begin to imagine some of the complications, particularly in the US with the politics we have around pregnancy and abortion. So with that, I want to start by emphasizing first that when we talk about global governance of a technology that knows no borders, we've immediately come to face the reality that there is no real global law. There's really no mechanism for a unified policy around the globe, even if you thought we ought to have a unified policy. It's true, we have some international instruments like treaties, but with rare exceptions, they are not used for biomedicine. The one really important exception that does apply here, however, is the Oviedo Convention of the Council of Europe. And it does speak directly to that. I'll get to it in just a moment. For those that are interested in this field more generally, the Genetic Literacy Project has online a very useful map that's interactive, and it allows you to click on any country to look at the kind of regulatory stance and policy stance it has taken on human health applications of genome editing, gene drives that is changing, usually insects like mosquitoes, so that they don't, for example, carry malaria, and then releasing them in the environment to try to outpopulate the malaria-causing mosquitoes or the dengue-causing mosquitoes. And then agriculture, which would be plants and animals, often very much linked to genetically engineered foods. Because these are linked areas, although the politics underlying them will differ. So that in some countries, the really heated politics will be around genetically engineered foods. We see a lot of that in Europe, excuse me, in the US. Although that's certainly an issue, I would say it's more about embryonic and germline editing that has gotten people all interested in the interplay with reproductive politics. So it's helpful to see where there are commonalities and where there aren't. But let me go back now to the Oviedo Convention. Now, this was adopted before we had a method for making any changes that would be heritable. So some might say that it was an easy thing to say that any intervention that seeks to modify the genome should not be undertaken if it is going to introduce a modification in descendants. And that's even if the goal was to actually prevent or mitigate some kind of genetic disorder. It's a really bald statement, an absolute prohibition on so-called heritable germline editing. And people were very comfortable with this because you couldn't do it. And some of the concerns about making mistakes and having those mistakes reverberate through the generations, or imposing changes on what are by definition non-consenting future people, those concerns were obvious, and it was easy to pay attention to them when there was no offsetting benefit that could make a compelling case for why you should do germline editing anyway. One of the results is that if you look around the globe, we have a very diverse set of responses to these technologies. So in Europe, because of the Oviedo Convention and the number of countries that have signed into the Council of Europe Convention, generally heritable germline editing is just completely illegal. It's true some countries have failed to actually adopt the domestic legislation needed to implement their signatory status, but nonetheless, it is basically illegal. There's, I think, a really interesting question about what's going to happen in the UK. They never signed on to the Oviedo Convention to begin with. And now, as they divorce themselves from the European Union, they're also divorcing themselves from some aspects of its politics. The United Kingdom has a highly regulated system for embryo research and all reproductive technologies involving embryos through the Human Fertilization and Embryology Authority. The tight regulation they have in the UK over exactly which patients can have things done for which kinds of indications by which particular physicians in which particular clinics, so, you know, soup to nuts kinds of control, has allowed them to become more aggressive and more adventurous than other countries, including the US. So the United Kingdom, for example, is the first place to use so-called mitochondrial replacement. That is a difficult thing to do in other countries that don't have that confidence from the same level of control. And in general, somatic editing is viewed throughout Europe, including the UK, as just another form of cell and gene therapy. So it's subject to the same kind of pre-market clinical trial approach, followed by an approval process with limited indications and some degree of off indication or so-called off-label use by professionals. By contrast, if you go to China, you have a really complicated, I find very confusing and relatively unregulated situation. They've had a series of individual laws passed to govern things ranging from in vitro fertilization to human cloning, but they don't have some comprehensive law that makes it clear what things are and are not allowed. It's why, as you'll see in a moment, it was possible for the first gene editing experiment on embryos to go forward in China without much oversight. And at the level of research oversight, where in the US, for example, and most other countries, we have a robust system of local oversight committees that are schooled in what is permitted and not permitted under the law and schooled in the developing norms around the ethics of human research. In China, there are upwards of, I think it was 5,000 of these local boards with vast variations in the sophistication that they have, not only in kind of ethical norms about what is and is not permitted, but even in what the law actually says. And last I was there, which was just as the pandemic was beginning to develop in China, as I was having dinner with a doctor from Wuhan, they were talking about the need to begin to rationalize their system and increase the level of education among these committees and develop a more centralized governance body. As far as I can tell, that effort has been stalled for reasons I think we can all imagine. In the United States, we have a very complicated situation because so much of our regulation is geared at the research level to funding conditions, as opposed to outright legality or illegality. For example, with research on embryos, there is a ban essentially on the use of federal funds, but you can do it with private monies. You can do it with money from certain states that fund this. California just once again voted in favor of a very substantial sum of money to go towards stem cell research. And if you are developing a cell therapy, that has to go through the FDA. At least there, the funding doesn't matter, whether it's private or publicly funded. When you're now developing a product, the FDA's regulation will kick in. But the FDA looks at things from a risk-benefit balance. They're not there to make social judgments about what is socially disruptive or morally problematic. They are there to look at the risk-benefit ratio. That's not to say that those things don't have values embedded in them. If a benefit is largely to let people have genetically related children, then you have to ask, how important is that? That's a value judgment that has to be balanced against the risk of injury either to the parents or to the resulting child. So the FDA can't evade this completely, but they can evade it somewhat. With regard to germline editing in the United States, we have a peculiar situation, because the edited embryo is now considered to be a manipulated cell. And if you transfer that into a human body, you now have triggered FDA regulation over tissue transplantation. It's not an intuitive finding, but it is the way the law is currently interpreted. That would mean that you couldn't start a clinical trial with germline editing for reproductive purposes in the US without getting permission from the FDA to begin that clinical trial. And they would only give that permission following a substantial showing of data from in vitro and animal experiments to give us a good expectation that the benefits would be reasonable in relation to the risks. It can't be done right now. And it's not for scientific reasons. It's because the Congress has passed in its budgetary bills a restriction on the FDA's ability to use its time or money to actually even acknowledge an application to start such a clinical trial. So by this kind of backhanded motion, we've made it impossible for somebody to legally begin a clinical trial. But those budget bills are re-legislated every 2 years. So it is a question whether or not that provision will ever get dropped out. If it does, it opens the door to the possibility of clinical trials for germline editing in the US, but it doesn't ensure that the FDA would ever say that they think it's safe enough to try, nor does it answer the question of whether or not, as a policy matter, we want to make it something that people can do in the United States. Now, I think that most people are probably familiar with what happened in November of 2018 when our International Summit on Genome Editing in Hong Kong was essentially hijacked by the news that Dr. He Zhonghui had now edited the embryos of a number of couples, had a number of those embryos frozen in storage, and at least 2 children had been born following gestation of those embryos. His purported goal was to edit to introduce a sequence, a mutation in the CCR5 gene that would render the children resistant to HIV infection. It was a misguided effort for many, many reasons, not the least of which is that he did not have nearly the kind of preclinical work you would need in order to make such an edit successful. And indeed, he did not achieve the edits he thought he was going to get. And to this day, we don't have information about the health and well-being of those two girls that were born, because there's really been an information lockdown on that situation. But just to emphasize the kind of paucity of the legal situation in China, after investigations of this really rather premature and I think fundamentally irresponsible experiment, Hu Zhonghui was not convicted of violating any of those various laws that I had mentioned in passing. The only one they were able to convict him on was practicing medicine without a license. And so it is an illustration of how difficult it can be sometimes to regulate in this area where it's hard to predict at any one time what the next new technology is going to be. At the global level, we've now moved on to two major international efforts to look at this topic. The first one I want to talk about is the narrower one, which is the International Commission on the Clinical Use of Human Germline Genome Editing. It's quite a title. It was organized by the Royal Society in the UK and the US National Academy of Medicine and the National Academy of Sciences. Although its construction, its statement of task, and the naming of members was all done with consultation with academies of science and medicine from around the world. Its focus was entirely on germline editing, and it grew directly out of that Hong Kong experience with Hu Zhonghui. Specifically, if we assume that in the future, many countries will say germline editing is illegal, but some will not say that. Some may either have no law or they will affirmatively say, yes, we permit it. How could it ever possibly be done responsibly from a technical point of view? The idea was, let's figure out what all the steps of preclinical research are needed in for both in vitro and animal in order to make it possible to ever meet the standards of a responsible regulatory agency, whether it's the FDA or the European, Canadian, Japanese, Australian, regulatory agencies, so that when they reviewed a request to start this clinical trial, they would actually have the information they need to judge whether or not it was safe enough to try. By contrast, the World Health Organization was asked to set up a committee to look not just at germline heritable editing, but also to look at the full world of somatic editing, basically anything on human editing as opposed to agricultural, and to talk about not the technical issues, but the governance questions. How should we think about this on a global scale? So the International Commission spent a fair amount of time looking specifically at what kinds of genetic diseases would be most appropriate for germline editing. Again, I have to keep saying it, assuming a country wanted to permit it, and which ones might be more problematic. And this is where we begin to get the first discussion of therapy versus enhancement. And I'm going to pick that up later because I think it's more of an issue in the context of somatic editing. They also wanted to look very specifically at the kind of protocol that they would need in order to validate the quality of an edit. Remember, I said that Hu Zhonghui did not get the edit he expected. So if you are doing edits, you have to be sure that, first of all, you're not going to get unintended off-target edits of unknown significance. That if you do, you know how to find them and to evaluate them in terms of what they do to the safety of the resulting person. And you also want to evaluate the stability of an edit, even if it's an on-target edit. Is it going to actually remain edited, or is it going to mutate at some advanced rate for some reason? How to evaluate mosaicism, because if you are editing an embryo, you're not going to be editing every cell of the embryo. And so as the embryo grows, we've got to figure out how many cells remained unedited and what degree of mosaicism will be acceptable. If you were to edit gametes, you could ensure that the resulting embryo would not have mosaicism, but that enters a whole other field of uncertainty, because you now need to basically manufacture gametes using iPS cells, using induced pluripotent stem cells, which is another step in the process, introducing more possibilities for risk. So in neither editing of gametes in order to have no mosaicism or editing of embryos in order to avoid the problem of the gamete production, do you have a situation in which it's very easy to assess what level of risk we're looking at. And finally, they wanted to talk about the ways to assess these risk-benefit balances and design some kind of tool that could be used to help obtain informed consent against a backdrop of a situation in which we really don't have a lot of information by which to inform people about what they are consenting to. I'm not going to go through these very dense slides in depth. I just wanted to highlight a few things. This report came out in September. Excuse me just a moment. And I think one of the first and most important things is that it concluded, as we did as well when we did the National Academy's report in 2017, that at this point, nobody should be trying to establish a pregnancy with an edited embryo because we don't have nearly enough information. They also said we need extensive societal dialogue. This may be something we should talk about in the Q&A because this is the mom and apple pie recommendation that you'll get from everybody, but nobody yet has figured out a way to actually achieve that in a global population in the billions, nor is there any real consensus about the role that that dialogue should have. How definitive should it be? And are our political systems where people simply vote directly on a referendum or indirectly on a member of the legislature to set policy, and whether that is an adequate basis for societal dialogue? They also said that if a country has decided to do this, allow this to be done, that they should do it on a very narrow set of conditions. And again, I gotta say, they really followed very closely with some of the things we said in 17. And that was that it should be limited to serious monogenic diseases. And I think very interestingly, particularly to avoid both unknown risks as well as the kind of lurking concern about enhancement, that if you are correcting a sequence that would otherwise lead to one of these serious monogenic diseases, what you do is you correct it to a sequence that is common in the human population or in that family. And the reason you do that is because then we know how that gene operates in that context, that environment, so we have some sense that it's actually safe and functions well. And it also handily means that we're not going to be inserting something that puts people on the far ends of the human spectrum of capacities. They'll neither be super tall nor super short, super strong or super weak, but they will wind up somewhere in what we would intuitively call normal. They also said, as we did again in the National Academies, that this should be limited to people who have very, very poor alternatives for having children that are genetically related to them. Ordinarily, most people can manage that if they're willing to discard embryos through either pre-implantation genetic diagnosis or at the fetal stage through selective abortion following diagnosis of a problem in utero. For people that can't accept that possibility, gene editing is viewed as a possible way to so-called rescue an embryo. And then there are the very, very limited situations in which you have parents that are homozygous for conditions that would pass the trait on even in a heterozygous child. They went on at great length about the capacities for a competent regulatory body. This actually moved into the terrain of the WHO committee to some extent. But really what we're looking at here is the need to have a regulatory body that is both technically capable of evaluating the science in order to do the risk assessment, but is also capable of making sure that people who are being recruited into these trials are people who understand what they're getting into, and that the long-term follow-up, which might even be multi-generational follow-up, has been anticipated through funding, through funds that have been set up so that there'd be money for monitoring long after the current investigators and physicians have moved on, that there'd be some kind of continuity of monitoring and periodic check-ins on the health status of the children and the children's children who have been born following these procedures. This is a challenge so big, it's unclear that any regulatory agency could take this on at this time. But there was an agreement that if you're making heritable changes, you need to be able to surveil for heritable problems. And finally, they made a recommendation that there ought to be some kind of international body that could help to serve as an ongoing assessment of the state of the science, to make that available to policymakers and regulators who need to be making decisions about germline editing. They were asked, but didn't really take on the task of dealing with one of the stickier problems, which is the ethics of, well, I'll call it the ethics of tattletale, or you can call it whistleblowing. Because there were many people who had suspicions about what He Jiankui was doing in China. And yet, despite that fact, there was no obvious place a person could go and say, I have a concern about He Jiankui. There was no obvious regulator in China, let alone whether a scientist in Germany or France or Argentina or the US would know how to go to somebody in China. There was no obvious funder that you could go to. There was no professional society kind of catcher's mitt for these kinds of concerns. And so instead you had a rather disorganized swirl of people who each knew a little bit, but not everything, who were talking to one another. There were rumors, there's mumbling, but there wasn't a good way of trying to catch irresponsible research before it moves to the state of actually producing children. That really became part of what the World Health Organization committee has taken on. That's the committee that I'm on. Again, I want to emphasize that I'll speak a little bit about what the committee's doing, but these are my own opinions. The first thing that, that developed out of this committee was the recognition that you need good facts to do good ethics, and you need good facts to do good policy, and we didn't have a lot of facts. So we wanted to start by having an international registry that lets us know who's doing what kind of research and what kind of clinical trials. Now remember, no clinical trials have started with germline editing, so for the moment it's only somatic that we're talking about, but it's a start to see whether or not we can draw from all of the national registries of clinical trials and put them into a central registry so that we have a sense of the range of somatic efforts that are going on. Getting germline experiments to be registered is going to be a more difficult problem because it is not as obvious that the national registries are going to have any kind of way in which individual in vitro research is being registered in an organized fashion. And that's what we really want to catch, is the in vitro work that's going on before you move to a human trial. In addition, we have taken on topics that the International Commission was not going to have to take on. We recognized again that permissibility was going to vary, particularly on germline, but we needed to talk about cross-border coordination and regulatory recognition. If, for example, and this is not an unrealistic example, a couple in, let's say, France, where the germline editing is forbidden, were to go to a country where it was legal, for example, because the religious makeup is different, therefore the politics is different, I'll say, let's say Israel decides that it will be legal but regulated. So a French couple goes to Israel, has editing done, and then comes back. Is this going to create any problems in France for the resulting child, or even for the parents who engaged in an act that would have been criminal in their home country but was clearly legal where they went? I say it's not hypothetical because in France we are still struggling with the problem of people who cross borders in order to do surrogacy arrangements, come back with a child who is yet to be properly recognized and affiliated with the parents who came back because of France's opposition to paid surrogacy. We also noted that we need to have, for somatic therapy, which I think is a much, much bigger issue, not only a solid regulatory system that can handle cell and gene therapies generally, but that now we really have to deal with three very distinct issues. One is the issue of enhancement, because it's one thing if I have, for example, sickle cell anemia, and you do somatic therapy so that I no longer suffer from sickle cell, we all say, oh, well, that's therapy. What if you had magically a vaccine against sickle cell? Would that be therapy or enhancement? It's aimed at preventing a disease, but it is about increasing my capacity to resist a disease, just like every other vaccine that we take. All right, well, maybe that's still about, it's still about a disease situation, okay. We do this a lot though, not just vaccines, right? Anybody in the audience who's ever had cataract surgery, I would bet when they replaced the lens in your eye, they didn't give you back the crummy eyesight you had all your life. They gave you 20/20 in that lens. That was an enhancement over what you used to have, but still within the range of human capacities. We do cosmetic surgery. That's enhancement. It has risks too, real risks, but we tolerate it. So we tolerate enhancement in lots of settings, and the question is, would you tolerate it here? And where might it occur? The fact is, in most cases, the kind of somatic editing that you would need to address diseases like the retinal diseases that are currently in clinical trial or the sickle cell are not going to be amenable to some kind of enhancement. But muscular dystrophy may turn out to be different, because the same technique that might help kids with muscular dystrophy retain or grow their muscular capacity to some extent might be adaptable to people who already have what we would consider to be a healthy muscle capacity, but want to increase it. One way to tackle these things is to ask about risk and benefit. The benefits are going to be marginal if you're taking somebody who's already functional and just making them function a little better, given that there always are risks. But at some point, the risks are going to reduce and we'll have to face these questions. And in some ways, they go more deeply to competitiveness and how much we tolerate it in every other part of our lives, but do we want to go ahead and tolerate it here? Second, again with somatic, although in theory germline as well, genome editing tourism. In the area of stem cell research, we found that the hype around stem cells, the confusion about the long-standing therapies with adult stem cells being conflated with the new areas of research and potential therapy using embryonic stem cells and induced pluripotent stem cells led to many, many people thinking that there was a magic cure out there if they could only get it. And we saw over the last 20 years a terrible growth in the number of completely fraudulent snake oil clinics all over the world advertising any number of cures for any number of diseases using any number of things that they kind of called stem cells. And because if you Google them, they all show up on the same page as legitimate clinical trials. They also mix up what is in experimental stages with stuff that has been done for years, like bone marrow transplant. It becomes almost impossible for the uneducated consumer of this information to distinguish real from illusory. And so it sparked global stem cell tourism. People tromping around the world looking for magic cures for everything from Parkinson's disease to Down syndrome. And there were many people who were actually badly injured, not just financially, but in terms of physical effects. People who've been blinded by some of these things, at least one death. And it has been a long, hard road to try to get a handle on this. Amazingly, we even have it here in the US where in theory, the FDA could have shut it all down. But from an enforcement point of view, it was almost impossible to do that at the scale at which this stuff was growing. I think that somatic editing may very well result in the same kind of hype that leads to unrealistic hope, and where you have countries with very poor or absent regulatory systems and a history of these kinds of fraudulent clinics popping up. I think we may see them also for somatic editing. We've seen a lot of this happen in the Ukraine and certain Caribbean islands, to some extent in Mexico. And I worry that if we are not on top of this, that we are going to run into that problem again. So that's another reason the WHO is looking hard at the cross-border issues about how we can identify problematic practices and how we can somehow use the power of international dialogue between countries to shut some of this down. Last and absolutely not least, as I come close to the end of this lecture, I want to mention access issues, because anything having to do with cell and gene therapy is going to be very expensive. We already have some of these therapies, and they're coming out at hundreds of thousands, even occasionally over $1 million a shot, which can make a lot of sense over the lifetime of a patient, because if something works for a lifetime after a single intervention, then you can amortize the cost of that intervention over however many decades. Especially for a child, you might be amortizing over 70 or 80 or 90 years. So certainly there's payback. But in the US, we have a very particular problem, which is that our fragmented health insurance system means that if my health insurer today is asked to cover my cell therapy, that insurer is unlikely to be reaping the benefits 5 years from now or 50 years from now, when I am now still disease-free and not using health services and not costing them money, because by then I've moved on to a different insurer because I have a different job. In countries that have national systems, it's a little bit easier to take a long view on budgeting, but even there, the costs are so high per patient that there is simply a lot of pressure to use that money to help 1,000 other people with less expensive problems rather than putting the money into that one patient. A problem that is not dissimilar from some of the tensions around certain organ transplant budgets. So cell therapies are really challenging us to think about the business model by which we have high prices for the initial therapy to offset the incredibly expensive research and development for not only that therapy, but all the others that failed, and reward the sponsor who's come up with a successful therapy with a big price tag and a long period of time of exclusive marketing rights so that all of that high price can be turned into profit to offset the losses. It's just not going to work. And we do have some techniques for trying to incentivize investment in things that otherwise would not get investment because the market doesn't really work for them. Orphan diseases that have very few people or have people only too poor to actually pay a lot of money for them, tropical diseases. These are things that in the US, in the European system, are incentivized through other things to try to tempt a sponsor, whether it's a longer period of market exclusivity or it is a voucher that they can use for something else that is profitable in their line, like fast tracking them to the head of the review line for a drug that might be a blockbuster. But that's another area that needs a lot of real thinking. It sounds like a business problem, but in the end, it's an ethics problem because it is about trying to make it possible for these things to be available. At the global level, it's a technological problem as well. For things like sickle cell, right now we are already testing therapies, but they're in vitro. Take bone marrow from the sickle cell patient, you take it out of the body, you manipulate it, you edit it, and you put it back in vitro editing. Extremely expensive and takes very sophisticated facilities. And that may be okay in the US, although even here that's going to be a challenge. But sickle cell is most endemic in West Africa, where in most parts of West Africa, this is simply not feasible. Neither the cost nor the facilities are available at the scale we would need. And so we need investment at a technological level to think about ways to make these technologies workable under different circumstances. In this case, to figure out an in vivo system that might work better in those settings. Similar to how with the vaccines for COVID-19, you're trying to think about how to make things really available. The vaccine that probably is coming out first from Pfizer, taking a cold storage chain that is at 100 degrees below 0 Fahrenheit, not being feasible for parts of the country, and then looking to see, can you make a vaccine that can be stored at a less severely cold temperature like Moderna, or like the more traditional vaccines coming out of Oxford and Johnson & Johnson, even at room temperature. So you've got both financial and technical issues when it comes to access. I'm watching the clock now. Basically, at the end of the day, it's important to have coordination, not harmonization. You want to simply be able to make it possible for companies to deal with one another, anticipate where there'll be conflicts and sort them out in advance without having to rely on them to come up with exactly the same policy, both because of cultural differences in their attitudes about embryos and about reproduction and about the importance of genetic connection, and also realistically about their capacity to regulate. I did say I wanted to mention these two areas that are coming up soon, so I don't want to end without mentioning them. In utero editing, I went to a fascinating conference at UCSF last year when I had the good fortune to be at Stanford for a year at the Center for Advanced Study in Behavioral Sciences, and wandered around the Bay Area, just gobbling up conference materials. And UCSF had a meeting about in utero editing for multi-system conditions in which by the time a child is born, so many organs have been affected that editing at that point may not be feasible because you have too many sites, too many targets. And cystic fibrosis was mentioned because although most of the public thinks it's all about respiratory illness. In fact, it also affects digestion, it affects fertility. So what if you could intervene before all those organ systems began to be affected by the mutations that cause cystic fibrosis? If you could do it at a time when you could identify the problem in the fetus, and you could also ensure that you're not going to affect the gonad, the developing gonads and gametes, well, then you've got a non-heritable form of editing, but you've actually tackled multiple problems in a child. That's likely not to happen until the second trimester. As a result, it immediately begins to get caught up in the battles around abortion, where we're already facing many state legislatures that are trying to move the period of permissible abortion back in time quite significantly to areas of time that would be well within the second trimester. So would it actually be ethical? Sorry, excuse me. Would it actually be ethical to do something like this at an experimental level if you didn't have pregnancy termination as an option in case things went really badly? The last thing you'd want to do if you're in an experimental setting, still trying to work this out and intending to try to do something therapeutic for the resulting child, the last thing you want to do is introduce another problem on top of the cystic fibrosis. So it might be that this is something that is coming, but it won't come in the United States because the politics around abortion will simply make it too complicated. Epigenetic editing. So this is where you could really talk about things that are temporary and even reversible changes. And that's very exciting because it really changes the risk-benefit balance. You might get lots of benefit when you need it and reduce the risk because you can reverse the situation. Theodore Ernov talked really quite persuasively about one of the dilemmas this poses, and it's the so-called dual-use dilemma. It's true for a lot of technologies. They can be used for good, but they can be diverted to bad. So he said, if we have terminally ill cancer patients, some of them are dealing with excruciating pain. And the only options we now have is for them to either suffer or to take painkillers that also make it difficult for them to stay alert and interactive. And so they wind up losing the opportunity for their last days, months, or weeks to be shared with family and friends. What if you could use epigenetic editing to temporarily change their pain receptors so that they don't experience that pain? He said every doctor would be lining up to get that for their patients. Why wouldn't you? Especially because if they're terminal, the risk issues are now also minimized. But the Department of Defense has a program looking at advanced therapies and advanced technologies, and certainly you can imagine the value of being able to temporarily edit your warfighters so that they would be less prone to pain in the course of an active theater of war, and so be able to continue fighting longer or be more resistant to the kind of torture or other kinds of interventions if they were to be captured. Do we really want to walk down the road of figuring out what is or is not an acceptable form of augmentation for warfighters? Again, we do this already with drugs and with special training techniques. Is genetics any different, especially when it's temporary? But it is the kind of discussion that one has to have. I'm going to conclude simply by saying that when it comes to governance, it would be important to just think broadly, not to limit ourselves to formal regulation from an FDA or FDA equivalent, but instead to think about an ecosystem approach in which you have many elements that are all reinforcing one another in imposing and enforcing ethical norms. So journal editors who are increasingly requiring evidence that researchers abided not only by local jurisdiction, but by ethical norms before they're willing to publish an article. Attention from insurers, not just health insurers who decide what to cover, which drives the market, but liability insurers who could have a very important role in helping to shut down these snake oil salesmen and their fraudulent clinics if they were to say, we will not insure you against injury because what you're doing is unproven and unsafe. The absence of insurance and the threat of liability might actually be enough to drive some of them out of business. And then, of course, professional societies, not only state medical societies that have some formal power, but the professional societies can use the power of the badge of prestige of membership as well as the educational function and the possibility of providing that kind of catcher's mitt for reporting and discussing areas of concern, they might also be a very important part of the effort to try and make this area of genome editing an area of research that really does serve to promote human health and minimize any of the societal or individual damage it might cause. And with that, I'd like to thank you and stop, and happy to answer questions if I can. Thank you.
Thank you, Professor Sharrow, for that talk. So we do have a couple of questions in the Q&A, and I'll be reading them aloud. So Andrea Stein points out that it would appear that there are online self-CRISPR kits available. So she was wondering, one, your thoughts on that, and particularly the legitimacy of these, but also, do these pose any kind of special challenges for regulation, given your conversation?
I'm going to speak in the US context because I don't feel like I'm expert enough on the European or Japanese regulations and such. So first, what do I think of them? I think that they are an example of Darwinian behavior. People stupid enough to try to edit themselves are the most likely to get injured from editing. So a little bit of self-selection here. Seriously, it's foolish to do things before you really understand them, and it's foolish to think that you're not biased in your own evaluations. It's why we do use regulatory agencies with dispassionate reviewers to try and assess the data. It may be that someday do-it-yourself, DIY, gene editing could be safe, but interestingly, the FDA does have the power to regulate a kit. Maybe not always the individual elements of it, but as a kit, it can often regulate to make sure that it actually will perform the way it's claiming to perform and do what it's supposed to do. The DIYs do pose a tremendous challenge from a regulatory point of view, because the FDA regulates things that are going into the marketplace. If you are not selling this, you can largely evade FDA regulation. I remember once when I was I used to work at the FDA, and I remember once coming across a video of some people showing how you could use engineered glowfish to make glowfish sushi. And you could have glow-in-the-dark sushi rolls. Putting aside, you should look it up on the internet. Putting aside whether or not you think that's a good idea, I thought, that's gotta be illegal. It's gotta be illegal. And I remember sitting at my desk at the FDA for a whole afternoon trying to figure out how this was illegal. But the fact is, they weren't trying to sell it. They were just having a little YouTube video showing, whoa, look what we can do, isn't this cool? So that does pose a real problem. If these guys were ever to try to sell it, then they would be immediately under FDA jurisdiction and there'd be a way to get at them. There are other possibilities, but I don't think there's so much regulatory, there's some truth in advertising. Again, it begins to hit the market. Yeah, honestly, it's hard to imagine outside of tort liability with somebody bringing a case saying you persuaded me to do something dangerous. And there, I think you'd have a hard time even winning that case. So, sorry, Andrea.
So Stuart Finter asks, the challenges of governance seem to bring together a variety of forces, chief among them science, industry, and government. All three, as we continually see, are swayable by economics. So how do you see the economic influences being kept at bay?
I'm not sure that, well, I'm inferring from the question that we ought to keep them at bay. I'm not sure we should. The economic influences can be very helpful because they lead to investment in things that we really do want and need, and to innovations that we come to value tremendously. I think that for me, the role of government is to identify market failures and intercede so that they don't leave some people out in the cold. And it's exactly why I was talking about how the model for drug development and investment has been manageable, although we're now seeing the need to have price controls of some sort on even widely used drugs. But it's been manageable, and you really do see much more innovation coming out than you would if we had a straight government investment program that was driven by some kind of committee. But it does fail when you've got disorders that don't affect enough people to provide a fast return on investment. And that's the kind of thing where I think we need, desperately need a new kind of innovation and, incentive system. By the way, antibiotics suffer from exactly the same problem. We really want investment in new antibiotics. It's an expensive thing to do, but once you get a new antibiotic, what you want to do is not use it. You want to hold it in reserve so that when you develop antibiotic resistance in a patient, there's something that they've never had before. So how do you incentivize people in the industry to invest in something that they're not going to be able to sell for a profit? You need a completely different system. And I actually I'm somewhat optimistic that we'll get there eventually, because the Infectious Disease Society of America has been plugging away at this for years. And some of their ideas about milestone payments, co-investments, may turn out to be the answer to this wider set of concerns. We've also seen, by the way, with COVID-19, some very interesting experiments in de-risking the investment in new therapies. So with Operation Warp Speed, companies were guaranteed a purchase at scale, even if, or payment for purchase at scale, even if things failed. So it allowed them to move forward more quickly on a wider range of possibilities than they would if they were trying to do it all by bets all along the way. And that may be another model that we should be looking at for how to incentivize things that would not otherwise get attention.
Thanks. So Steve Peckman asks, you noted the International Society highlighted the imperative for societal dialogue about genome editing. Does the issue regarding use of the emerging technologies regarding enhancement warrant a societal dialogue specifically about the goals of medicine and whether genome modification and editing for enhancement purposes achieves an agreed upon goal of medicine?
Oh, Steve, you always ask such hard questions. First, I still don't know what a societal dialogue is. And I've spent a lot of time on committees that have recommended we have societal dialogue. And I sit there trying to understand what we're actually recommending. That's not to say I don't believe in those things. And in fact, I've got a marvelous colleague here at Wisconsin, Dietrich Schäufele, who works on this. But what he's taught me is that you have to be asking first, what is it you're trying to get from this dialogue? Is it that you simply want to educate the public? That's kind of a unilateral direction. Do you want to be gaining information from the public that will inform your expert or governmental policy, ethics, decision-making? Do you want it to be some kind of iterative process? Do you want the public's views, whether not, naive or once properly educated, to then drive policy, control policy? Until you know what the goal of this interaction is, it's hard to know how you can structure it. On enhancement in particular, I think that is one where it is essential that we ask about it in different contexts. We are very sloppy in our thinking about what we're trying to accomplish sometimes. In boxing, we have flyweight, middleweight, and heavyweight. So clearly in boxing, which by the way, I'm not advocating for, but they have these different groups. And what they're really trying to do is even the playing field so that you can really be having a battle of training and grit. Basketball. Steve knows me, so he knows I'm like 5'1"1/4" or something like that. I'm never going to play basketball. And they didn't have a short person basketball league. They didn't care if I had a lot of strength and grit and speed. They only wanted tall people. So why is it that in some areas we're pretty clear about what we're testing for and others, what we're measuring in competition and others not? It's like the difference between the A for effort versus the A for performance. So I don't know that we can have a kind of universal answer about enhancement, whether it's surgical, medical, or genomic, that crosses all these different settings, whether it's educational or it's athletic or it's health resistance or it's longevity. Let alone whether genomic has to be handled differently than the others. So I think that might be one where if we could organize a conversation within the parties that have a particular interest in those fields, we might be able to get a more organized discussion.
I'm actually going to take advantage of my role as the moderator to follow up on Steve's question, in part because I am interested in this question about competition. As you noted at one point, you mentioned that one of the things we would have to think about is our tolerance for competition. I was also wondering, though, about, it seems like we would need to, in these kinds of conversations, be sensitive to the effects of competition for winners and losers, in effect. So in some societies, right, they have much more robust, say, social safety nets, right, or welfare programs where the effect of being a loser in certain kinds of competitive spheres, I hate using this language, but since we're on this analogy, the effect of being a loser is far less devastating than it is in a society with a less secure social safety net. So I was wondering if you could speak a little bit about how these facts about different sort of economic arrangements within different countries, right, might inform these societal dialogues about questions like competition, and whether that actually could be an impediment to something like a global governance structure, or would it call for very minimal global governance structure, or if it were more substantive, would it have to be one that would mitigate those kinds of harmful effects, almost like in accord with a maximum principle like Rawls?
So I used to have two colleagues on the faculty here, both feminist scholars, both named Jane, and yet they had different ways of approaching things. And one tended to be more about procedural aspects of equality, and the other one more about outcome. And there was a joke about the Miss Jane versus Ms. Jane approach to feminism. But it reflects notions about equality, whether it's equality of opportunity, and then wherever people go, they go, versus equality of outcome. And it's an impossible debate because we never have a society in which people actually do start from the same level playing field, right? So we're trying to graft a theory of equality onto fundamentally uneven levels of advantage. And it's not even a linear hierarchy of advantage. I might be advantaged in terms of, let's say, athletics, but not intellect. Somebody else has intellect, but not athletics or music or whatever. So I don't think we're going to have a global approach to this. I think different societies will inevitably have fundamentally different degrees of tolerance for varied outcomes, whether it's because of varied origins or because of varied accomplishment against a backdrop of evened out origins. I think in the United States, the one argument that might make some inroads is the need to equalize the starting point. That, by the way, was where the Bill Clinton administration was going in some of its rhetoric, right? Get everybody to somewhat more equalized starting point, and then let's just let them go where they're going to go. But it's funny, I'm just now watching The Crown, which just started up again on season 4. And they have an episode, we have several episodes with Maggie Thatcher. And oh my God, I remembered now. I'd forgotten all this, right? But those of us of an age remember those years. And you know, her view about the inevitability of inequality and the need to tolerate it because it created a space for economic growth through the accumulation of capital. So a Maggie Thatcher England is going to have a fundamentally different culture than Denmark, where more outcome equality is a focus. That's where the social safety nets come in. And it'll be different from the Bill Clinton America having to do with at least starting places being equalized. I don't think that's bad. I don't think we ever know really what the right answer is to all these things. It is like a laboratory of experiments. But I have a personal preference, but I don't think that my preferences need to, you know, run the globe. Sometimes I do, but not always.
So unfortunately, we have run out of time, Alton. I want to thank you most sincerely for a wonderful presentation. It was extraordinarily informative. And it was also, there was a penetrative analysis there and a wonderful handling of questions. So I only wish we had more time to share with you, but thank you sincerely on behalf of the Ethics Centre and our whole scholarly and caring community here at UCLA for giving the 2020 Weinberger-Vermut lecture. And I would also like to thank again both Tom and Leslie Weinberger for their extraordinary generosity to the center and through the center to the UCLA community of learning.
You're very welcome. It was truly a pleasure. Thank you for having me.
Okay, thank you.